All right, here in 9.0 we start solving what we call like non-factorable quadratics. We just finished a whole chapter over factoring. So you can see we got ourselves a quadratic equation right here. And what I'll do is approach it like maybe I would try to factor it. Well, first thing first is to totally get that to be a 0. So I'm going to subtract 13 from both sides. You can just watch this, by the way, because it's not going to do much good, right? Because, okay, I have subtracted 13 from both sides, and I got myself a minus 20. And you know what? It's very true that there's a GCF that I could take out of here. 10 could go into each one of these terms. So if I factored out a 10, I would be left with x squared right there, and then minus 2 in the parentheses equals 0. And even though we could factor out the GCF, it still didn't do us much good, because what's left in here, you know, since it's only two terms, is not a difference of squares. Like x squared is a perfect square, but 2 is not a perfect square. So this method of taking out the GCF on this guy probably didn't do us much good. So here's how we'll approach it, with something called the square root method. The square root method can be used anytime your quadratic equation has x squareds, but it doesn't have any x's in it whatsoever. Like there's no x to the first. So what do? You try to get that green x squared all by itself. So what I would do first is actually like add 7 to both sides, which of course you don't have to show that baby step, but you kind of see what I'm doing there. I added 7 to both sides. But I want to get x squared all by itself, so I need to divide both sides by 10, right? So if I divide by 10, divide by 10, I'll be left with x squared equals 2. And this is why it's called the square root method, because once you get x squared all by itself, and there's no x's at all, you can just square root both sides, right? So if I square root this side and square root that side, those cancel each other out, and I think we're pretty good at realizing there's actually two answers there. It's going to be plus or minus the square root of 2. And that's going to come out nasty, right? Like square root of 2 is not a 2 is not a perfect square, so we're just going to leave it. Like to type it into the computer, it's square root of 2 and negative square root of 2, and it probably doesn't matter what order, just read carefully. So let's do one more of those. Even if this was a difference of squares after I factored out a GCF and got them ready to run, the square root method would be a great way to do it, because there's only x squareds in this equation. So I am actually going to add 7 to both sides. So I'll get that 18x squared all by itself. And then I will divide both sides by 18. So 90 divided by 18 is 5 in that case. So I get me a 5. And the idea, again, for the square root method is to get x squared all by itself. Remember, it can't have x to the first in it. We'd have to do something else. So when you get x squared all by itself, you can square root both sides, and x will equal plus or minus the square root of that guy. And then you have your two answers. Don't forget that if this guy could simplify, let's say that that was the square root of 8, you know, just kind of making something up, then you would have to break him up into two radicals, because 4 goes into there evenly, right? So it would go in there twice, so that becomes 2 square roots of 2 in that case. So if the radical can simplify, we will simplify the radical. But our answer to this guy was the square root of 5, and he cannot simplify in that case. So square root of 5 and negative square root of 5. Let us know if you have any questions. Have a good one.